All right, here we go with the last lesson of the unit and also the last lesson of the semester. And it is very similar to the last lesson. Okay, so solving equations versus solving inequalities. Starting there. A solution to any equation or inequality is any ordered pair that makes the equation, inequality, or system true. So in general, a solution is something that makes something true. A solution to a system of equations is found at the intersection of the two lines, which is why there is only one solution, because there's only one intersection of two lines. A solution to a system of inequalities is found in a region of the graph created by the two lines, which is why there are infinitely many solutions, because a region is made up of an infinite number of points. Okay? So, how many regions were created when we had one linear inequality? That was what we did with the last unit, or last lesson. That made two regions, right? How many regions, and I'm going to say typically because there is exceptions to this, how many regions will be created when we have two linear inequalities, which is what we're doing today? Well, if each line makes two regions, I'm going to be getting a total of 4 regions. How many of those regions represent the solutions to the system of inequalities? One of them. So one of the 4 regions is going to represent my solutions. And I'm going to try and use a couple different colors to show you what's going on here. Okay, so the first one. I'm going to go quickly because it's just 2 of what we did with the last lesson. So first one's going to be dotted. Second one's going to be solid. Put that. Now I'm going to do the first, everything with the first one, I'm going to do that first. Y-intercept is 0. 1/2 is the slope, so up 1, right 2. And it's dotted. And I shade south. So I'm going to shade lightly here. Make sure you shade, that's key. Make sure you shade lightly. It'll save you trouble in the, later on. Now this one we haven't seen in a while, but that's a vertical line. X equals 1. Well, where does x equal 1? X equals 1 here, and here, and here, and here. It's a vertical line. It's solid. Well, where are the numbers bigger than 1? To the right. Right? All these numbers on this side are bigger than 1. Okay? Now, I'm going to use a different color to hopefully show you this in a little bit. No, I'll use it now. I think it'll help. So, we have 4 regions. I'm going to outline the 4 regions. So, there's a region. Basically, I'm just tracing the 2 lines. There's a region. There's a region. And there's a region. Okay? So, region 1 up here is those are solutions to the first or second equation only. Region 2 down here, those are solutions to the first equation only, because it's shaded only by the first equation, or inequality. This one was only shaded by the second one. The third region here has no shading at all, so it doesn't work for either one of them. And the fourth region, notice how it's shaded, one's going down and one's going over. It's shaded twice. Those are your solutions because they're shaded twice. So I'm going to go back in and I'm going to shade them either a different color. I'm going to shade them darker. There's my solutions. Okay. Here at the bottom it says give 2 solutions to this system. Any 2 points in that region. So I would just say, I don't know, 4, 0, and I don't know, 3, -6. And you could check those. You could put them in for x on both of these. Half of 4 is 2. Is 0 less than 2? Yes. Okay. 4, 0 for this one. Put 4 in for x. Is 4 bigger than 1? Yes. Try the other one. What's 1/2 of 3? 1.5. Is that bigger than negative 6? Yeah. And then put 3 in for x. It's bigger than 1. It works for both. Okay? Let's do the second one. Notice how I'm doing these. I do one at a time. So this one's going to be solid. Okay, I'm going to graph that and go down to 2. Up 1 over 1. Okay. If you try to graph both and then shade, you're going to get confused. It happens all the time. But this one's shade south, so I'm going to shade below lightly. I'm going to move stuff around here. I'm going to add 4x, so negative 2y is greater than or equal to positive 4x plus 2. Then we're going to divide by negative 2, which flips the sign. So less than or equal to negative 2x minus 1. And by the way, this one's solid also. Okay, so solid. A lot of dots right here, but make sure you get the right ones. Okay, and I'm going to shade south of that one, which means this way. Where does the shading overlap? It overlaps in this region right here. Give two solutions to this system. Something down in here, so I'm going to start with 0, negative 6. That's an easy one. 0, negative 6 is right there. And I'll go with negative 1, negative 7. There's more, but those are two that I see. Okay? Moving on. More examples here. 3x plus 4y greater than or equal to negative 8. I'm going to get it alone, so I'm going to have 4y is greater than or equal to negative 3x minus 8. So I'm going to have y is greater than or equal to negative 3/4 x minus 2. Solid line. So minus 2, negative 3 over 4. Draw my solid line there. So a shade above. Okay, so do the second one. We'll subtract 6x. I get negative 8y is greater than or equal to negative 6x minus 16. Divide by negative. As soon as I say that, I should be flipping the sign. Less than or equal to, that's positive 3/4 x, positive 2. And again, this is solid. So positive 2, up 3, right 4, down 3, left 4. And I'm shading below that one. And where's the overlap in the shading? Hopefully you see that pretty easily. Now I changed the question out a little bit here. I said, is 5-2 a solution? Well, you can do this a couple ways. I would say the easy way is 1, 2, 3, 4, 5, 1, 2. It's in the shaded region, yes. But that's a good way to check to see if you get it right. Take 5 and 2 and put them in for x and y, should make true statements here. So 3 times 5 is 15, 4 times 2 is 8, 15 plus 8 is 23, that's definitely bigger than negative 8. True there. 6 times 5 is 30, 8 times 2 is 16, 30 minus 16 is 14, definitely bigger than negative 16. It works for both of them, so it is a solution. Okay, last one, kind of. This one's ready to go, but it's dotted. Move up to 4. I'm going to go up 3, right 2. Down 3, left 2. Down 3, left 2. And I'm shading above there. Next one, I got to move stuff around, so I'm going to get negative 4y greater than negative 6x plus 8. As soon as I divide by negative, I need to flip the sign. That's a positive 3 over 2 x minus 2. Oh, and it is dotted also. Up 3, right 2, up 3, right 2, up 3, right 2. less than. Where's the overlap? Well, that's weird. There is none. Okay, how many regions were created in this problem? Well, there was only 3. Why? We had parallel lines, which means there was no intersection. Okay? So we have 1, 2, 3 sections. How many of those regions represented solutions? None. None of them had overlap. A solution here only worked for the first one. A solution here only worked for the second one. There's no part in this whole thing where it worked for both of them. Now, is this always the case? No. Let me give you an example. I'm just going to flip both of these signs. So y is less than 3 over 2x plus 4. And I'm just going to go to the simplified version over here. So I'm going to switch that sign too. Y is greater than 3 over 2x minus 2. So basically what would happen here is we would have first line, second line, but this one would shade south, and this one would shade north, and the middle would represent solutions to both. And that's the bell, and I'm all done. If you have questions, let me know.